We introduce Sensorimotor Realities, a new concept in the landscape of computer-supported and extended reality. Sensorimotor realities capitalize on the diversity of human sensorimotor abilities, which are those organismic factors that the individuals bring with them when learning a new task, and various sensorimotor abilities enable a diversity of skills in everyday life. Examples include visual motor coordination of the arm, hand, wrist, and finger for accurately touching targets on the small screen of a wearable, or dexterous movement and coordination of the fingers for assembling tiny Lego pieces into complex structures that support creative play. Sensorimotor abilities are also affected by the context in which they are applied. For instance, a person with spinal cord injury may need two hands to use a TV remote control, and a wheelchair user may need a supporting surface to effectively employ a tablet from the space of the wheelchair. Other sensorimotor abilities used in context enable a blind person to understand the form factor of a head-mounted display by moving the hands across the device. Finally, the same sensorimotor abilities that make humans effective in the physical world are leveraged for interactions in new environments that feature synthetic stimuli. All these examples show how sensorimotor abilities are repurposed in a process of mediation to support new skills and interactive experiences. It should follow thus that the design of computer-mediated worlds and interactive systems needs to capitalize primarily on users' sensorimotor abilities as these abilities undergo mediation. In this context, we make several contributions. We introduce Sensorimotor Realities, a new conceptual framework depicting a new type of reality with distinctive characteristics in the XR landscape. We propose a six-dimensional conceptual space for sensorimotor realities to characterize and compare interactive systems addressing mediation of sensorimotor abilities in computer-mediated worlds. We introduce Ability-Mediating design, a complementary approach to ability-based design for which we outline distinct principles such as mediation of perception and action, world coverage, and instrumentation of the body and the environment. Finally, we propose a research roadmap for sensorimotor realities and present our vision of computer-mediated worlds where users' sensorimotor abilities are mediated to support a diversity of readily accessible skills and interactive experiences. Sensorimotor realities relate to other types of computer-supported realities, including virtual, augmented, mixed, mediated, and multi-mediated reality. In the following, we adopt the formalization employed by Mann and colleagues to examine these concepts as supersets and subsets. For example, augmented reality is a subset of mixed reality according to Milgram and Kishino's reality-virtuality continuum, and mixed reality is a subset of mediated reality according to Mann. Multi-mediated reality includes not just interactive multimedia-based reality for the available human senses, but also additional senses and human actions actuators. In this landscape, sensorimotor realities have a distinct scope from existing reality concepts, which are agnostic to differences in human abilities and thus do not offer the necessary tools to characterize changes in those abilities. In contrast, sensorimotor realities capitalize on the diversity of human sensorimotor abilities as these abilities undergo mediation to enable new skills and experiences in computer-mediated worlds. We adopt a principled approach to contour the distinctive nature and scope of sensorimotor realities in this landscape. The relativity principle of sensorimotor realities states that human abilities vary in time and place, and generally, in the context in which the world is perceived and interactions with the world take place. According to this principle, each of us experiences every day a variety of sensorimotor realities. The many worlds principle states that sensorimotor realities focus on interactive experiences in worlds representing diverse mixtures of the physical, virtual, and imaginary, where sensorimotor abilities are needed. The instrumentation principle states that sensorimotor realities focus on ability mediation implemented with wearable devices and smart environments. Based on these principles, we introduce an operational definition for sensorimotor realities as dynamic manifestations of the reality subjectively experienced by a computer system user as the result of associating perception and action mediated by wearable devices and smart environments. We also introduce a conceptual space with 6 quality dimensions to address mediation of sensorimotor abilities in new computer-mediated worlds. The sensory and motor mediation dimensions specify the nature and amount of mediation of perception and motor action respectively, for which we distinguish among amplification, extension, diminution, and reduction. For example, sensory amplification refers to enhancing users' abilities to sense external stimuli, such as increased color perception with smart glasses. Sensory extension refers to enhancing abilities beyond the possibilities offered by the human anatomy and biology, such as seeing in the thermal domain. Also, new motor skills can be enabled beyond one's anatomy, such as a 6th finger to grasp and hold large objects. Opposed to amplification, we identify sensory diminution, where one's sensory abilities are purposely worsened. And opposed to extension, we identify sensory contraction, where an entire sensory ability is refused to the user, such as virtual training with simulated hearing loss. Diminution and contraction also apply to restrict the limits of motor action, either by reducing or refusing a motor ability altogether, such as wrist braces that prevent rotation of the wrist for the treatment of the carpal tunnel syndrome. World coverage is implemented with the virtuality and imaginarity dimensions. Virtuality represents the amount of virtual content presented to the user. It is implemented with Milgram and Chișinău's continuum, with the physical world at one end and the virtual world at the other. Imaginarity represents the degree in which mental imagery is needed for effective operation in the world. For example, the user may rely on their memory to access digital information they believe is located in the physical world. The instrumentation principle of sensorimotor realities is implemented with the body and environment augmentation dimensions. Body augmentation specifies the use of wearables to mediate sensations and movement. We see this dimension as a continuum ranging from no use of devices to increasingly more complex networks of body sensors and actuators. Environment augmentation specifies the integration of sensing, processing, and visualization technology in the physical environment to mediate sensorimotor abilities. Examples include video projections, shape-changing furniture, and physical telepresence mediated by a reconfigurable environment. These dimensions are organized in groups of 2 in relation to the principles of sensorimotor realities. The origin of the space denotes the physical world with no augmentation, where one's sensorimotor abilities are not mediated by computer technology. Note that dimensions 1 and 2 allow negative interventions, such as diminution and contraction, while the other dimensions interpolate between dichotomous concepts, physical-virtual, physical-imaginary, and unaugmented-augmented, respectively. Due to their focus on sensorimotor abilities, sensorimotor realities connect with ability-based design, a design approach that promotes interfaces that are general yet flexible to address a range of users, but also interfaces that are personalized to specific user groups or individual users. 7 principles guide practitioners of ability-based design. For example, ability means that designers focus on users' abilities instead of disabilities. Availability means that technology should be affordable and available, and according to adaptability, interfaces provide the best possible match to users' abilities. Computer-mediated reality creates a new scope for accessible interactive systems compared to that of ability-based design, since it enables designs of systems that center on abilities undergoing a process of mediation. To address this aspect, we introduce ability-mediating design, to characterize how sensorimotor abilities are amplified, extended, diminished, or contracted in worlds that are mixtures of the physical, virtual, and imaginary. Based on the definitory principles already adopted for sensorimotor realities, we proposed 3 design principles for ability-mediating design. Mediation means that sensorimotor realities mediate perception and action to empower users with new skills and experiences. World coverage means that sensorimotor realities cover many possible forms of world existence, physical, virtual, imaginary, and combinations thereof, representative of the physical reality, computer worlds, and mental imagery. To achieve sensory-motor mediation, the body and/or the environment are instrumented with computer technology. Devices designed to be worn are in contact to the body parts that feature sensory and motor functions to enable mediation within the self, while instrumentation of the environment enables mediation external to the self. Sensorimotor realities bring the perspective that human life can be seen as a series of varying sensorimotor abilities that enable different realities in terms of what humans perceive and how they act following those perceptions. To further investigate these matters, we propose several directions for future research on sensorimotor realities and ability-mediating design. For example, we picture a future world in which users can access on demand a diversity of computer mediation of their sensorimotor abilities in context, likely without even paying attention when transitioning between one set of skills to another. A myriad of sensorimotor skills and corresponding interactive experiences in and with mixed worlds would become readily available to users as a direct consequence of world designs primarily centered on mediating existing sensorimotor abilities. For more details, discussion, and an example of applying ability-mediating design for a practical application, please see our paper. Thank you for watching.